Good morning. You are welcome to Seat of Wisdom SOWTtv. Today we shall be considering magnetic field. When we're talking about magnetic field, it simply means a region surrounding a magnet within which a force is exerted on any other magnetic substance. When a charge Q moves around a velocity v in a magnetic field B, the magnetic force is given by F equal to QVB sine theta. And another thing is that when it's not acting upon any angle, we have it ordinarily as F equal to QVB, where F equal to magnetic force in Newton, that is, it is measured in Newton, velocity in meter per seconds, magnetic field, it is measured in Tesla or measured in Weber per meter. Then the angle that is between the velocity and the magnetic field. Note, if V and B are in the same direction or parallel to each other, that is, when there is no angle formed or we have a 180 degree, that is, there is no what? It means that the angle, the F is equal to 0. Yes, the F is equal to 0. That is, when V and B are perpendicular or at right angle to each other, then theta can be 90. Therefore, F is maximum. When V and B are parallel, the F is equal to 0. But when V and B are perpendicular, the F is maximum. So we now have another thing. We have what we call the flux on a current carrying conductor. This is given as F equal to BIL sine theta. It also has a condition. F is 0 when B and I are parallel to each other. Why F is maximum when B and I are perpendicular. The same condition that we have for magnetic field is also equivalent to the same condition that we have for current carrying conductor. Let's proceed. We have quiz that we are going to treat today. I'm giving us two quizzes to treat. Let's consider the first one before we move to the second one. A proton moving with a speed of 1.0 times 10 raised to the power 6 meters per second through a magnetic field of 1.0 Tesla experiences a magnetic force of magnitude 8.0 exponential minus 4 Newton. What is the angle between the proton's velocity and field? Solution. Don't forget, as I always say, that we write out your parameter first. We are given a velocity to be equal to 1.0 exponential 6 meters per second and magnetic field to be 1.0 Tesla. The magnitude of force exerted on the proton is 8.0 exponential minus 14. Then our quantity of charge is a constant value for both proton and electron. Proton is positive, electron is negative. 1.6 exponential minus 19 coulombs. Going by the formula, F equal to QVB sine theta. We make our sine theta the subject of the formula. Then we have it to be F over QVB. We substitute our parameter 8.0 exponential minus 14 over 1.6 exponential minus 19 multiplied by 1.0 exponential 6 multiplied by 1.0. If you press your calculator very well, and for the sake of those that be involved in any exam that they will have no access to calculator, you can have 8.0 over 1.6 times 1 times 1. Then your exponential will be in one place using the law of indices. When you have times 10 to the power minus 14, when minus 19 is coming up, it's changed to plus. When 6 is coming up, it's changed to minus. Then you have it together, you are going to have your answer like that. Then sine theta equal to 8.0 times 10 to the power minus 14 over 1.6 times 10 to the power minus 19. Then we divide both sides. We divide it 8.0 divided by 1.6. We have our answer to be 0.5. So 0.5. Then we are left with sine theta over 0.5. What are we going to do next? That is, divide both sides by sine. Sign cancel sign on the left hand side. So on the right hand side, we are going to have it to be sine inverse of 0.5. Sine inverse of 0.5 is equivalent to 30 degrees. That is our answer for the first quiz. So let's move on to the second quiz, when we will be looking at a force on a current carrying conductor. Yes, on a current carrying conductor. A conductor of length 2 meters carries a current of 0.8 ampere while kept in a magnetic field of magnetic flux density. That is, another name for magnetic field is what we refer to magnetic flux density. Though we have what we call magnetic field intensity, is different from magnetic flux density, which is equal to 0.5 Tesla. Calculate the force acting on it. In this question, we are not given any sign, any angle, which means that both the current and the length, they are parallel to each other. So I have to write out the parameter as usual. Our length is equal to 2 meters. Our current is equal to 0.8 ampere. Then our magnetic flux density equal to 0.5 Tesla. Going by the formula, F equal to BIL. For mnemonics, F equal to B. By the time you remember F equal to B, you should be able to remember easily what we are referring to. So substitute our parameter, multiply everything together. We have our final answer to be 0.8 Newton. Thanks for watching. Don't forget to like, comment, share. I wish you best of luck.